In this video, we will create a simple dataset object and apply transforms to it. In this video, we will review how to build a dataset class and object, how to build a dataset transform, how to compose transforms. To create our own dataset class, we must import the abstract class dataset from torch.utils.data. We can then create a class toyset. This is a subclass of the dataset class. Let's use the box to represent the object and its important data attributes. The values of our features and targets are created in the object constructor and assigned to the self.x and self.y tensors respectively, each with 100 sample. We also store the number of samples in the attribute length. We'll discuss transforms later. When we apply the function len to the object, as we override the method len in our object, the function will return the attribute length. This is the number of samples in our dataset that we defined in the constructor. In this case, the value is 100. The dataset object behaves like a list, tuple, or any Python iterable. We call the object with a square bracket, representing the index we would like. This square bracket acts as a proxy for the method getItem. This method in turn returns the sample indexes corresponding to tensor x and y and assigns them to the variable sample as a tuple. We will refer to these the first tensor in the tuple as tensor x and the second tensor as tensor y. This corresponds to the following values. The variable sample is returned. The result is a tuple. The first element of the tuple corresponds to the first sample of x and the second element corresponds to the first sample of y. The dataset object is an iterable. As such, we apply the loop directly on the dataset object. We can use a loop to obtain the first 3 samples as follows. As you read, for the first iteration, the method getItem is called. This is repeated for each subsequent iteration of the loop, returning the first 3 samples. In many cases, we would like to transform the data, for example, normalize or standardize the data. Instead of writing a function, we will create callable classes. The objects we create from these classes will apply transforms to the tensors. Let's create a simple transform class, then create an object to see how it works. We create the class addMultiply. We will apply this to the data in our dataset, toy dataset. Let's see 2 ways how to apply this transform to our dataset. We will add a number to the first tensor element in our variable sample or tensor x and multiply the second element in our variable sample referred to as tensor y. In the constructor, we have the parameters add x. The number we would like to add to tensor x and mul y is a number we would like to multiply the y tensor by. We also have the method call. The method acts as a proxy for the brackets. This will make more sense when we call the object. Let's see 2 ways how to apply this transform to our dataset. First, let's apply the transform directly to the dataset. Let's create a dataset object and see what happens when no transform object is passed. In this case, the parameter transform had no argument and is set to the default value of none. As a result, the attribute self.transform is set to none. When the getItem method is called, a none is passed. Python interprets a false. As a result, when the getItem method is called, the tensor x and y will be returned. We can apply the transform directly to the dataset. We create a transform object and we apply it to the first sample of our dataset object. If you recall, the dataset object returns a tuple. Each element corresponds to the tensor x and y respectively. When we apply the transform object to the tensor, the first element of the variable is assigned to x. The second element of the variable is assigned to y. The object adds the following, the value of add x to the tensors x. In this case, the value is 1, and multiplies tensor y by the value mul y. In this case, the value is y. We then reassign it to the variable sample. The value is returned. The result is 1 is added to the tensor in the first element of the tuple, and the second element is left unchanged. A more convenient way is to automatically apply the transform when we call the method. First, we create a transform object. We pass the object to the constructor as an argument. This time we add an underscore to the object name to signify that a transform object has been applied. As a result of the attribute self-transform is set to the transform object. In the original dataset object, when the getItem is called, the samples were returned without any transform being applied. If we examine the first sample of the object, where transform was included in the constructor, the transform is applied when the getItem is called, and each of these tensors have the transform applied to them. In many cases, we would like to run several transforms in series. You can do this using the class Compose in the Transforms module. In addition to our add mult, let's say we would like to apply another transform. In this case, we create the class mold. It will multiply all the elements of a tensor by the value mol. We simply create a Transforms Compose object. In the constructor, we place a list. The first element of the list is the constructor for the first transform. The second element of the list is the constructor for the second transform. We can apply the transform on the data directly. The function takes the input elements of the dataset, applies the first transform, applies the second transform, and returns the output as a tuple containing the tensors. We can apply the compose object directly in the dataset constructor. Each time we retrieve a sample, the original tensor is passed to the compose object, the first transform is applied, then the second transform is applied.